A human being cannot possibly live longer than 125 years.
Many, many years ago, didn't people live to be hundreds of years old?
All of us have these poor lifestyle choices, poor genetics that accelerate our cell division. 90% of all the reasons we die are related to aging, so that's why I'm focused on trying to cure the aging process. We're not going to cure aging unless we first solve this telomere shortening problem.
Our days are literally numbered.
They are. It's an actual ticking clock. I sometimes compare it to a stick of dynamite that's burning and that fuse is going, and there's nothing we can do about it.
I'm surprised that there isn't a way already to manually somehow lengthen telomeres. Do you think that we're going to get there?
We do have a way to lengthen telomeres now, and that's what we haven't gotten into yet. Before this podcast's over, I'm going to tell you what we can do about it.
Before we begin today's episode, I just want to say thank you for being here. Your presence is truly appreciated, and every single subscriber we are so grateful for at the Heal Within podcast. If you are not yet subscribed, please subscribe. It makes us able to continue with the show and put out this valuable information so that people can have a holistic, natural healing journey. And that's why we're here. That's the purpose. Thank you so much. We're grateful for each and every one of you. Enjoy today's episode. Dr. Andrews, you've said before that the key to living longer isn't just adding years to our lives, but adding life to our years. How do telomeres fit into that vision of extending not just our lifespan, but our health span?
Well, a lot of people, and I have a lot of colleagues that are into anti-aging and trying to do research and stuff like that. And we all get this message from people like, why are you trying to increase lifespan without increasing health span? And it's like, there isn't a scientist on the planet that doesn't mean health span when they say lifespan. Okay, so that is always the thing. But that's why I came up with that slogan, let's see, the National Institutes of Aging came up with that slogan, I want to say 30, 40 years ago. But they said, life before years before life, something like that. And I just changed it to say, let's do both. Okay. But that's what lengthening telomeres would do. Telomeres isn't just going to make us live longer. We don't want to be like, you might be too young to remember Zardoz, the movie Zardoz, with Sean Connery, who was also James Bond and other movies. But they showed people that they had the cure for aging, but now all these people were in beds, hospitalized. They couldn't do anything except exist. And that's not what we want. I want people to be playing tennis, dancing, having the time of their lives when they're 150 years old. And that includes myself, especially. So what we haven't really talked about what telomeres are yet, but telomeres are the key in humans, at least, not in rodents and not in many other animals, but the telomeres are the key that limits our lifespan and our health span. Okay, so telomeres are like ride tickets at an amusement park that are found inside of our cells. And every time a cell divides, it loses a ticket. And therefore, our lifespan is limited by the fact that our cells can only divide a certain number of times. And in order for our bodies to be able to perform their normal bodily functions, such as our liver function, our kidney function, our heart function, there is a minimum amount of cell division that has to occur just to keep those functions going. And when you calculate that and the number of ride tickets you have, you find that a human being cannot possibly live longer than 125 years, okay, because of this number of ride tickets that we have. And people think, oh, this is just a theory. Well, it's not a theory, okay? It's been known since 1961 when Leonard Hayflick published that he found that human cells can only divide a certain number of times. When you take cells from a young person and divides them, he can get certain number of divisions. Well, let's say from a newborn baby, he can get 50 cell divisions. From a middle person, he can get 25 cell divisions. From a 90-plus-year-old person, he gets less than 5 divisions before the cells totally stop dividing, lose the ability to function, go into a phase called senescence, and die shortly afterwards. And so this is, I mean, people still think this is a theory, but when anybody doing research in a lab on human cells orders cells from a company like the American Type Culture Collection or something like other source of cells, they look at the catalog on the website, and it says how old was the person that these cells came from, and how many times have these cells divided before they were put into these tubes that you're going to buy, test tubes that you're going to buy. And from that, you can calculate exactly how many times those cells can divide before you can't do any more experiments on them. And this isn't a theory, this is a fact. This is a fact. We are limited. But I know the questions, my answers are often too long, but I'm just so obsessed with this field, and it's frustrating listening to a lot of people talk about how there's all these other theories about aging, but aging's never going to get cured unless we also solve this limit to our lifespan, this which is caused by telomeres, and we'll come to that when I give you a chance to talk.
No, your answer is great. It's perfect. My first thought is, okay, so our goal would be to slow down the separating of the cells, but then I basically heard you say that you can't do that. There's a certain amount of speed that happens, so you can't necessarily slow down that process. But then you said also that we're capped at 125 years. And I'm wondering though, I mean, many years ago, didn't people live to be hundreds of years old?
You know, there's a woman you might want to talk to, Natalie Coles, who's actually, I think, the world's leading expert on centenarians and supercentenarians. And she's done a lot of research into that. And right now, it looks like the best explanation for that is that people used to define a year as full moons. Okay, so they didn't, like, people were closer living to the equator, so they didn't really have the seasonal changes and stuff like that to distinguish between winters and things like that. So their definition of a full year was every full moon. So Methuselah lived to be 969 years old. Okay, this is how often I get asked this question because I know exactly how many years he lived. But when you calculate that in terms of full moons, it turns out to be 73. Okay, and so that's probably the best explanation. But it doesn't mean that Methuselah and Noah didn't exist. Okay, I mean, and it doesn't, like, I respect religion tremendously. Okay, and all the beliefs and things like that. And I believe that everything I'm going to be talking about is no more proof of anything real than religion is. Okay, I just want to cover all the bases, make certain that I cover everything. But the thing is that religion is easy to explain. Okay, if we want to figure out why we live so long and things like that, God did it. Okay, but now, just in case God didn't do it, what are the other things to look at? And so I'm looking at the other approaches too, and I'll tell you, they're a little tougher to solve. Okay, and I personally don't want to be lying on my deathbed thinking, oh, I chose the wrong route. So I literally am focused on every different possibility of trying to extend lifespan, because living's the greatest thing that ever happened to us. And I just hate the thought that living can become any less lovable for any of us just because of this dumb thing called aging and our limit on our lifespan. And if I could go back for a second, because I did say that our ride tickets limit, or our telomeres limit our lifespan to 125 years. And there's no way to slow it down, slow the cell division down and loss of ride tickets. But that's below the basal level. Okay, everybody accelerates their cell division by poor lifestyle choices, sometimes by poor genetics. So that's why nobody's ever lived to be 125. And if you get a chance to talk to this Natalie Coe's person that I mentioned, um, she'll tell you that even like this person, Jean Calment, who supposedly lived to be 122, it's now well documented. Nobody's ever going to prove it, but it's very likely that her daughter assumed her name and position when her mother died. Her mother died, and then I forget her age when she died, but the daughter assumed the position to avoid inheritance taxes. And then when she got to like 90 something, I think she lived to be 90 something, but everybody thought she was 122. She couldn't say, I lied, I faked it. She just went along with it because she didn't want to end up paying all those back taxes and stuff like that. But it's like most certainly nobody has actually lived to be 120 even, because all of us have these poor lifestyle choices, poor genetics that accelerate our cell division and accelerate. And believe me, before this podcast's over, I'm going to tell you what we can do about it. But I'll tell you, this is a serious problem, and it's the thing that limits our lifespan and our health span. You'd be amazed at the studies that we have done and the accomplishments that we have had that have actually show we can do something about it. Uh,
Yeah. Okay, great. I would love to talk about the things that we can do for the sake of longevity, but before we get into that, I'm wondering what are the things that we're doing today that shorten that? But before you even answer that, I want to get a clear picture for the listeners who are hearing about telomeres for the first time, what those actually look like. Because I know you talked about the process of the cell dividing. Isn't there a tail or something? Isn't it because it's the length of something and it shortens? So I'm trying to imagine what that's like. And at what point does it get so short? Does it just go away, or how does that work?
okay, well,
So
telomeres
many
are
questions.
found at the very tips of our chromosomes, okay? And I mean, chromosomes are where all of our genes are that give us our hair color, eye color, make some of us smart, make some of us not smart, make some of us tall, short. There's all these, we have 25,000 different genes, and they're organized along this string of beads called DNA. The beads are made up of 4 different types of beads called bases. A, G, C, and T is what they are. And it's the sequence of those beads that dictate what color hair we have and eye color, etc. And these genes are located along these beads, and next to every gene is a dimmer switch. A dimmer switch turns the gene on and off, and that's why some of us are taller and some of us are shorter and things like that. Okay, so at the think of this long string of beads as a shoelace. Okay, at the very tips of your shoelaces are these caps called aglets, and they protect your shoelace. Okay, our DNA has the exact same thing. They're just called telomeres instead of aglets. Okay, they're found at the very tips of our DNA, and they protect our DNA. Now, we've also found that they do more than just protect the DNA. They actually play a role in regulating the dimmer switches that control the genes. And so when every time a cell divides, the telomeres get a little bit shorter. And they don't get shorter because of degradation or anything like you might hear if you do Google searches on it. A lot of people think they're being degraded. They get shorter because every time a cell divides, you have a parent cell, it's going to make 2 daughter cells. Every time that parent cell divides, everything inside that cell needs to be duplicated so that the daughter cells end up with the identical things that the parent cell had. Okay, well, that includes the DNA. The DNA, which all our genes, the chromosome, the DNA is also called the chromosome, has to be duplicated. And the analogy that I like, it's like when the cell is duplicating that DNA, also called replicating the DNA. It's as if you were making a new row of bricks on top of a brick wall. Okay, and the top row that's existing now is the DNA that was there already. And now you're making this new row of bricks. And the bricklayer is standing on top of the wall, walking backward, laying a new brick every time it the bricklayer takes a step. Then when he or she gets to the very end of that wall, he or she falls off and can't lay a brick in the last place. So every time a cell replicates the DNA, the new DNA is made a little bit shorter because the machinery inside of our cells, which is very similar to a bricklayer, it's called polymerase. The machinery can't replicate the very end. And so every time a cell divides, the new DNA is shorter. And that shortness is by 40 bases, okay? And so we can think of that 40 bases as a ride ticket. So, and then, so when we are first conceived, when we are a single cell organism, our telomeres are 250 ride tickets in length. I mean, this is not theory, this is math. Anybody who has any experience with math and mathematical modeling and things like this know, and actually sequencing the DNA and seeing this, we know you were conceived, you have 250 ride tickets. And by the way, just think of another even theory on aging that has this much detail to it. Okay, you have 250 ride tickets. And when that cell divides to become two cells, the two cells now have 249 ride tickets left. Okay, now there's so much more cell division that occurs going from a single cell embryo to a newborn baby. When you were born, you only have 125 ride tickets left. And it turns out our lowest level of normal basal level cell division, okay, to make our organs function, our skin, our eyes, everything, make them all function normally. Our cells have to divide at least once a year. The slowest we can go is once a year, but that's about what it is. And that's so our cells divide once a year, so it loses about one ticket per year because we have a lot of growing up, we got wounds to heal, we got infections to fight. All these things require cell division. And then our liver functions, our kidney functions, all these things, they're in constant. There's the cells, there's frontline cells, okay, on our organs. These cells are where all the action is. Think of it like, think of the liver as a battle, okay? You got your frontline cells, you got your reserve cells, and the frontline cells is where all the action is, but their lifespan is like average of one year, okay? So every time one of those cells divide, you have to bring up a reserve cell to replace that. But when you bring up that reserve cell by cell division, it has a shorter telomere. So it can only occur about 125 times once you're born. Okay, so after 125 years, if you have slowed down the cell division as much as possible, 125 years, you can't possibly live another day because you don't have any way of replacing the killed cells from the normal bodily actions. Okay, this is, again, not theory, it's real science, and anybody who works with human cells and petri dishes can tell you this. Okay, but the world doesn't realize that we have a key to the aging process that exceeds anything else anybody's ever heard of. And as I said before, no matter what else we do to try to cure aging, we're not going to cure aging unless we first solve this telomere shortening problem.
Our days are literally numbered.
They are. It's an actual ticking clock. I sometimes compare it to a stick of dynamite that's burning and that fuse is going, and there's nothing we can do about it. So my research got going here.
Now, if we can't undo the shortening that's already occurred, what can we stop doing? What behaviors can we stop doing that will help them slow down from here on out? I'm guessing things like drinking alcohol.
Yeah, do the accelerated, so we can accelerate the rate of cell division. And alcohol is a really good example. Everybody knows that alcohol kills liver cells, okay? So the liver, these are the frontline cells on your liver. When you're drinking alcohol, you kill liver cells at a faster rate than they would normally die. And so the reserve cells are constantly having to divide to replace those killed liver cells. That's okay when you're young. Drink all you want. Kill all the liver cells you want because you have reserve cells that can divide to replace those cells. But when you get to be like 40 or 50, you run out of those reserve cells. And suddenly your frontline cells just become an accumulation of dead cells that can't be kicked out of the way and replaced because there's nothing to replace them with. You accumulate these dead cells, that's called liver cirrhosis, okay? And that's what kills you from the accelerated cell division caused by the accelerated drinking. But why, if we have this problem, why have we never evolved a way not to have this problem, okay? And that turns out, this is my PhD is in molecular genetics and population genetics. And population genetics is the study of why and how evolution occurs, not just the what and when you usually. So I've really learned about why have we evolved a way to age, or what's actually more accurate is why have we never evolved a way not to age? Okay, and it turns out evolution is not about survival of the fittest individual. It's about survival of the fittest species. And a lot of people get that wrong when they think about basic evolution. It's about, so the survival of the species requires that we have as much diversity within the species as possible to make certain that some individuals in the species will survive when there's a rapidly changing environment. And so it turns out that once you've reproduced and raised your young, you have added as much diversity to the species as you're ever going to add, okay? Because of ever since sexual reproduction, we have been shuffling our genes, which was the greatest evolutionary step ever to increase diversity within a species. We have person A, person B, they mate, they produce an offspring that's a combination of their genes, which never existed before sexual reproduction. So we have this great shuffling, but it turns out the diversity is going to be even better if the people get eliminated after they've raised their young, because then there's going to be more diversity occurring from the offspring interbreeding than the parents rebreeding. And so that's why we never evolved a way to not eliminate what I call the longer lived, instead of using the word old. Life's about living, not about getting old. So eliminating the longer lived actually increases the chance that the offspring will interbreed as opposed to the parents rebreeding, which increases diversity, which increases the probability that species will survive rapidly changing environments. And that's why we have never evolved a way not to get cancer, not to get heart disease, not to get Alzheimer's, because these are things that affect us after we've raised our young, not before we raised our young. The only evolution that's ever occurred is to get rid of diseases that occur predominantly before we raised our young. And we've done a good job of doing that. But more importantly, like things like mutations and things that we evolved that give us higher risk of cancer, heart disease, those are all by accident. They're not intentional. There's no force making it. But at the same time, there's nothing that is going to de-evolve that. There's nothing that's going to make it so those disappear. So we get this accumulation of all these things that kill us after we've raised our young. And evolution has never done anything about it. That's why I'm doing it. That's why my colleagues are doing it. We are now smarter than evolution. Of course, we made a lot of stupid mistakes, but we are smarter than evolution. We know what to do to actually overcome this result, because evolution is not a force, it's a result. This result of evolution creating all these ways that kill it, but these ways that kill us after we've raised our young. Okay, so aging is the main one, and 90% of all the reasons we die are related to aging. So that's why I'm focused on trying to cure the aging process. I want to be around when we make first contact with alien life. I've got these great pictures of me in the movie from First Contact, Star Trek, where humans are first shaking hands with an alien species. I superimpose myself with a three-way handshake just because I say, I want to be there when that happens. And I'm not going to be there. It's April 5th, 2063, I think it is what Star Trek says that day is going to be, but there's unlikely I'll be there by that time unless I cure aging.
I think you can do it.
Yeah.
In fact, the way that science is now, I'm surprised that there isn't a way already to manually somehow lengthen telomeres. Do you think that we're going to get there?
We do have a way to lengthen telomeres now, and that's what we haven't gotten into yet.
Steroids, antibiotics, birth control, Accutane. Sound familiar? Those are my options too, and none of them actually healed my skin. You try everything: cleansers, supplements, even changing your diet, but nothing seems to last. The breakouts come back and it starts to feel hopeless. I get it because I've been there. The truth is, most of what's offered to us only masks the symptoms. It doesn't address what's really happening underneath. If we want lasting results, we have to stop feeding the pathogens that are behind acne, eczema, and other skin issues. That's why I created my free no foods guide for clear skin. It shows you exactly which foods are unknowingly keeping your skin stuck. It's the first step to actually seeing results that last. Imagine waking up and loving what you see in the mirror again, feeling confident in your skin, in photos, everywhere. Start there. Download the No Foods Guide for clear skin below and check your inbox right after, and your spam or promotions folder just in case, so you don't miss it. Let's get your glow back from the inside out.
So I've been obsessed with aging my entire life. My father was the one that put the seed in my head, and he and I were partners until he passed away in 2015. We would go to anti-aging conferences together and things like that. But I was convinced, and also my best friend later got a Nobel Prize in medicine, but he and I used to, his name was Bruce Boiler, or is Bruce Boiler. He and I used to talk about aging when I was in college. Okay, what is the cause of aging things? And we came up with this ride ticket and amusement park analogy to explain it. But it was like, what are these ride tickets? And so it wasn't until the early 1990s that I actually heard somebody speak at a conference and talk about the fact that telomeres shorten every time a cell divides. And I'm sitting thinking, here's those ride tickets. And so I went up to the guy before he even got off the stage. I went to the guy and says, has anybody figured out a way to re-lengthen the telomeres, to make them longer? And he said, no, we've been working on it for years. We've been collaborating with labs all over the world. Nobody's been able to figure that out. And the reason why that was important is because to show that telomere shortening is the cause of aging, you need to lengthen them to show that it reverses aging. And then if that happens, then you know that telomere shortening is the cause of aging and also the cause of this Hayflick limit that we talked about. So I said to the guy, let me come and work in your lab and I will have it figured out in 3 months. And sounds kind of like a bold thing to say, but I actually had quite a successful career already in biotech. I'm one of the key inventors of human growth hormone, tissue plasminogen activator, uh, erythropoietin, osteoinductive factor, beta seron, a whole bunch of things, including several cancer drugs, one that's just got approved by the FDA just a few months ago called Rytelo, R-Y-T-E-L-O. I mean, so I had like a more successful career in developing treatments and stuff like that in biotech than anybody else. And so he offered me the job on the spot. And when I went to his company, he put 3/4 of the company, which is like 30 scientists, reporting directly to me. And 3 months later, we discovered this enzyme called telomerase. And uh, the, it all got started by the fact that, you know, here we got this thing about, we know that cells divide, we have this Hayflick limit, but now we know that there's a good chance that the reason for this Hayflick limit is because every time cells divide, the telomeres get a little shorter. But if that was true in all of our cells, if telomeres got shorter every time all of our cells divided, then how is it our children are born with longer telomeres than we have? So I reasoned that there has to be something in our reproductive cells called our primordial germ cells that are responsible for producing our sperm and our eggs. There had to be something in those cells that was preventing the telomere shortening. So that's what me and my team at Geron did. We focused on what's inside our reproductive cells that's not inside of our normal cells. And we discovered this enzyme called human telomerase. And so first thing we did was we put the gene for human telomerase into normal fibroblast skin cells from a human, put it inside the cells and let the gene, and we engineered it so the dimmer switch for that gene was turned on full blast, and just like it is in our reproductive cells. And we put that gene into the skin cells and allowed it to produce telomerase, and then started letting those cells divide and divide and divide. And they never reached the Hayflick limit, okay? This is the first time ever in the history of the planet that anybody had ever been able to take human cells, grow them in a petri dish, and not encounter that Hayflick limit unless they were like a cancer cell, which is out of control growth. But we showed that these cells were absolutely not cancer and actually had a decreased chance of ever becoming cancer, okay, which taught us a lot about cancer. By the way, I forgot to mention, I was National Inventor of the Year for my cancer research in the United States. So I do know a lot about cancer, even though I'm so obsessed with aging. I've been a very successful career in cancer research too, among everything else. But I do believe that our risk of cancer is related to aging. That's one of the main reasons why we have a much higher, tremendously higher chance of getting cancer after we've raised our young than before we've raised our young. Okay, so getting back to these cells, they became immortal. Now, we went even further than that. We then checked all the different genes. There's 25,000 different genes. They all have these dimmer switches. And when human cells get longer lived, these dimmer switches change to give off all the appearances of longer lived or older, which I don't like saying, but longer lived cells, okay? And we showed that not only did that not happen in these cells that we had put the telomerase gene into, the dimmer switch all got reversed to a younger type, okay? Let me take that one step further, because this suggests a Benjamin Buttons kind of situation. But it turns out that it only reversed the genes that were involved in aging, not development, okay? So turning these cells younger did not turn them back into baby cells. They turned them back into what would be the equivalent of a 25-year-old. So when we're first conceived, we have a lot of genes that are controlling development. Development kind of ends, 99% of all development ends by the time you're 25 years old. Then after that, all you do is age. That's a whole set of different genes. We only reverse the genes that affected aging, not development. So we realized right away, if we did find a way to do this in humans, not just human cells in a petri dish, we wouldn't be turning people back into babies. We'd be turning them back into 25-year-olds, feeling, looking, and behaving like they're 25 again. So the next step we did was, because who cares about human cells in a petri dish? Even though it did give us a major publication. But what we had to do is we had to now go one step further. So we took human cells and grew them into skin on the back of mice. And let me say that first, the reason we didn't use mouse cells is because mice don't have this Hayflick limit. And this is why it's actually, it doesn't make any sense that we're doing all this research on mice to try to study human aging. Mice don't have a Hayflick limit. And then we later found out that they actually produce telomerase in all their cells, and they don't have any telomere shortening. Their aging is completely unrelated to human aging, okay? I mean, there's a few health-related things that are similar between humans and things like mitochondrial dysfunction and oxidative stress and inflammation and things like that. But aging is not at all related between humans and mice and all rodents. So we had to grow the human skin on the back of mice, and then treated those cells with the skin, and we saw complete age reversal of every biomarker you could imagine. And this is like, and we saw age reversal in all the genes, the dimmer switches, when we were working with human cells in a petri dish, but you can't look at the cells and say the cells are younger. We wanted to see something where we look, this tissues looked younger and behaved younger, and that's the first time we saw that was with the human skin on the back of mice. We took that then one step further. We provided the machinery, the telomerase gene and other things, to a lab at Harvard run by Dr. Rhonda Pinnell, who actually had created rodents, mice, that did have telomere shortening, and they did not produce telomerase in all their cells. And so it turned out that they did age just like humans, but it was only this engineered mouse. Okay, so we provided him with our technologies, and he then took these mice that he allowed to get old or longer lived, and he then introduced the telomerase gene into these cells, into the mouse, in all the cells of the mouse, and saw complete age reversal by every method of measurement imaginable. And people don't believe this, but Diane Sawyer did an interview with him, and people can go Google and find Diane Sawyer and Dr. Rhonda Pinnell, Depinho, and they can find this like 5-minute news report where he shows the mice. And what was most exciting was that he showed that these mice that had gotten longer lived and had suffering from dementia and couldn't remember how to go through a maze, when he lengthened their telomeres and made them young again, they suddenly remembered how to go through a maze. And that was completely unexpected, because everybody believes that dementia and Alzheimer's and things like that is a loss of memory. How do you bring that memory back? Well, it turns out these might be just loss of access to the memory. The memory is still in your brain. When a person has Alzheimer's, the memories are still there. You just lost access to it. And telomeres, lengthening telomeres, restores that access. So I actually have a clinical study that I'm trying to get underway right now, where I want to see if we can lengthen telomeres in patients that have Alzheimer's and see if we can restore their memories. Now, we're doing this by a technique called gene therapy, which is super expensive and super risky. But if you are like 6 months away from dying from Alzheimer's, it's definitely worth the risk to try it. But my goal is, ever since before even Dr. Rhonda Pinnell did this experiment, because I was convinced long before, but what I'm trying to do at Sierra Sciences here is find ways of turning the gene on. Okay, I said our reproductive cells have the gene and are producing telomerase, and therefore our children are born with longer telomeres than we have. But I am now trying, and therefore all the genes in our body, all the cells in our body have the gene. It's just turned off. I'm working on trying to turn that gene back on. And we have like $1 million robots here behind the wall on the other side of me here is 10,500 square feet of lab space, where we have robots working, humans working, and we're testing up to like 4,000 different molecules, mostly plant extracts, looking for anything that can get inside of human cells and turn that dimmer switch on for the telomerase gene back on. And so we have found a lot of things. Nothing that works as well as gene therapy. Gene therapy is where we actually take the gene, put the gene into a virus, and then infect that person with the virus. And that delivers the gene just like it delivers its own DNA, the virus's own DNA, delivers the DNA to all the cells, including the telomerase gene. So now all of a sudden the cells produce telomerase at a very high level. Because we're using a virus, that kind of makes it a little risky, but we're using safe viruses to do this. But it's so expensive. I mean, it costs us $1 million to treat one person once in this clinical study. So it's not the kind of, I want to, when I have a cure for aging, something that turns this gene on, turns the telomerase gene on and makes us younger. I want to drop it from airplanes. I'm not in it for the money whatsoever. But so I'm looking for molecules, whether they're pharmaceuticals or nutraceuticals right now is irrelevant, but just because of educational, getting proof of concept. I'm looking for anything that can get inside of our cells and adjust that dimmer switch to turn the telomerase gene back on. And let me just jump to it right here. This is TeloVital, okay, sold by a company called Touchstone Essentials. This contains the most potent, what I call telomerase inducers we've ever discovered. We're not a marketing company, we're just a research company. So this company called me up 2 years ago and asked if they could market some of our discoveries, because we don't want to market. We're too busy trying to find the cure for aging. But I said, well, we don't have anything that cures aging. Like telomere shortening and lengthening is like a tug of war, okay? In our reproductive cells, it's a tie. We have lengtheners and shorteners. And in our reproductive cells, the only lengtheners is this enzyme telomerase. In all the other cells of our body, we only have the shortener. So every time our cells divide, we lose a ride ticket, one more and one more. Telomerase adds ride tickets back, but we don't have telomerase in all of our cells. So now I'm turning that gene on to actually put people on the other side of this tug of war, but we haven't produced enough to win the tug of war or even tie the tug of war, but we do slow it down. I told that to Eddie Stone, who's the founder of Touchstone Essentials. And I also told him that I've talked to other companies, and when I told them how, what they have to do to actually produce this product, they thought, oh God, the profit margin wouldn't be high enough. They weren't interested because they were only interested in profits. They weren't interested in the greatest thing ever to actually slow down the aging process. They weren't interested in that. They were only interested if it made them a lot of money. But Eddie Stone said, I don't care about profit margins. Okay, I want a product that actually is going to really benefit people. And he and I have been best friends ever since. So I then started working with a lab in New Zealand run by a Christian Chase, who's somebody else you might want to interview, who's I think a really great formulator. I'm not a formulator. I can test the nutraceuticals and plant extracts and other molecules for their ability to induce production of telomerase, but I'm not somebody that can prepare the extracts or know enough about plants to prepare the extracts, but Christian Chase is. And so he prepared all these. He took the 5 top nutraceutical fractions, and they're not just total extracts, they're fractions of extracts, because there's too many molecules in a plant to actually do anything, because there's going to be all kinds of competition between molecules. So we have to fractionate the extracts to smaller components to eliminate the things that are going to compete with whatever you want it to do. So we told him the top best 5 fractions, and he formulated them all, put them together in capsules, created the bottles, and then provided them to Touchstone Essentials that now sells them as this. And it's USDA organic, which is the only thing I've ever invented that has that kind of classification. Means the lead levels in this are below detection. All kinds of heavy metals, toxins are below detection. It's all vegan, and it's really great. But this thing induces telomerase expression inside of our cells. But so far, not enough to win the tug of war, but it is slowing the tug of war down. And what we have been finding ever since this product got launched, like I guess in last March, so March of 2025, it's a new product. But I meet with people like more than once a week, groups of people that are taking this product, because I'm interested in seeing the results. It's not really scientific. It's not a double-blind placebo-controlled study like I would prefer, but it's better than nothing. I'm talking to these people, and I'm seeing some major age reversal in some of the older people, like over 80 years old. And so trying to figure that out, we actually already had data that explains it. We just didn't put the 2s and 2s together until we actually saw it working. And that's that when telomeres get really critically short, they become easier to lengthen. And I've actually explained this in my books that I've written years and years ago, didn't connect the dots here. But and also videos that I have, I've explained why when telomeres get critically short, they get easier to lengthen. And that's what we're probably seeing now, is that even though we're not producing enough telomerase to win the tug of war in a young person, we are in a longer lived person with critically short telomeres. And there's also, because people accelerate telomere shortening, a lot of people are going to have critically short telomeres in a lot of tissues. And because of genetics differences, there's also going to be people that have critically short telomeres in tissues that even had nothing to do with poor lifestyle choices. Okay, so what I am seeing from some of these people I'm talking to is I'm seeing hair coming back in some people. I'm seeing hair color coming back in some people. I'm seeing vision coming back. My vision has even gotten better since being on this product. But I'm but this is probably because these people have some genetic thing that made their telomeres shorten at an accelerated rate in their hair follicle cells and things like that. And Televital might be lengthening those critically short telomeres and causing some age reversal. This is not scientific proof. This is just me making a best guess to explain why these things are happening. I've developed other products before, and there's always anecdotal data, and there's always people faking things. People say, "Oh, my hair color came back," but they colored their hair, and they don't want to tell their friends they colored their hair, so they're blaming the product on it. But there's just too much real going on. So I think that we are actually likely seeing critically short telomeres getting longer from this product, and so there is some age reversal going on. But I'm still doing research. Okay, my goal is to make it so that we find a plant extract, or if absolutely necessary, some type of pharmaceutical. Of course, a plant extract would be better because it wouldn't require the 12 years of average FDA approval to get it available. But plant extracts don't require that because they're already generally regarded as safe by the FDA. But I'm hoping that within like 3 years, we can find something that's potent enough to win that tug of war and start reversing aging in everybody. Okay, not just the longer lived people or the people that have critically short telomeres in some of their tissues. But and I can tell you we are getting a royalty from this product. Okay, we aren't doing any marketing, though it sure sounds like I'm marketing right now. We are we are getting a royalty, and that royalty is going 100% towards our research. And I didn't mention this before, but running these robots, and the robots need about 40 different scientists also working with them. That cost us about $2 million a month to do that research. So the funding that we're getting from Televital sales is actually helping with that, getting that research done. And if we can maintain that research level, I think we can have something. We can have a new generation of Televital that actually wins the tug of war and reverses all of our aging, especially mine, in 3 years from now. That's what I'm predicting, and that's extrapolating from all the data we have on all the nutraceutical and pharmaceutical and telomerase inducers that we have already found. Extrapolating at that rate, if we can continue our research, we should be there in 3 years at the most.
This is fascinating. I'll make sure to link the product in the description, but I do want to close the loop on the things that people can do on a daily basis to shorten and or not shorten. We want to stop the shortening and keep it as long as possible. So what are like the top three?
I'm going to give you more than three because there's so many,
Okay.
but let me just generalize. Anything that increases oxidative stress, which is damage to our DNAs from free radicals and things like that, or induces inflammation, causes accelerated aging, accelerated division, cell division, therefore accelerated aging. But smoking, obesity, drinking alcohol, those are probably three top lifestyle choices. But oxidative, so a lot of us, everybody's different, but everybody has sensitivities to certain foods, okay, and they're different for everybody. So I take a test called the ALCAT test, ALCAT, every year because it changes even in individuals. And I identify from the LCAT test what foods are causing inflammation in me, and I quit eating those foods. And so that's what I recommend everybody should do. They should quit eating the foods that cause inflammation. Inflammation is the #1 cause of aging. Anybody in my field will tell you that. Okay, but it's #1 because it accelerates telomere shortening, just like oxidative stress does. So, but things that you can do to stop it are, quit drinking, quit smoking, lose weight, but meditate, yoga, those things are really great for decreasing psychological stress, which I didn't mention. It's also a cause of accelerated telomere shortening. Reducing stress levels overall. I'm a keynote speaker often at yoga and meditation conferences just because I can show people data showing the length of telomeres. People that do yoga and meditation all the time have longer telomeres than their friends their same age that don't do yoga and meditation. But just there's so many different things. But pretty much everything that your mother told you when you were a kid about healthy lifestyles turns out to be true because the bad things you do accelerate your telomeres shortening. But there's just a lot of supplements you can take. Somebody else you might want to interview is Dr. Sandra Kaufman. She's written the best books ever on how to choose what supplements you should take. Everybody's, again, different, but this book really gives you the formulas on how to figure out what you should be taking, because most of those supplements stop the accelerated aging from inflammation and oxidative stress, and also mitochondria dysfunction, okay? And it turns out mitochondria dysfunction definitely decreases our energy as we get older, but people don't realize that even though mitochondria have its own DNA, 90% of a mitochondria is controlled by the nuclear DNA, which is controlled by the telomeres. So the telomeres, when telomeres get short, telomeres actually bend over and adjust these dimmer switches. So when the telomeres get shorter and shorter, they can't reach as far. So the dimmer switches are adjusted differently. And that's why we see the changes that occur with age. But by re-lengthening it, and that includes the genes on the nuclear chromosome that make the mitochondria. So by lengthening the telomeres, we actually can restore mitochondria to function, all the kinds of different functions that control DNA stability, like sirtuins. There's just an immense number of things that the telomeres shorten. Everybody talks about epigenetics, okay? We need to control the epigenetics, which means the dimmer switches, how much the dimmer switches is turned on and off. That's what epigenetics is. Telomeres control all those genes. The epigenetics, the one thing, telomeres can control all the epigenetics of why we age, how we age, things like that. And the people, so many labs are working on trying to find ways of working on each individual gene themselves individually. And it's because this is so crazy. It is so much easier to figure out how to restore health of a mitochondria, how to decrease oxidative stress, how to decrease inflammation than it is to control the length of the telomeres. But instead of taking all these anti-inflammatories to deal with all the inflammation problems and all the antioxidants to deal with all the oxidation problems and all the different things we can do to restore to undo mitochondria dysfunction, we could just do the one thing, telomeres. And nobody else wants to spend all their time and money on stuff like that except me. Because even though all those other things might provide some, I don't want to say anti-aging benefits, they provide health benefits. They're not going to cure the aging process. We are still going to be limited to 125 years maximum, unless we also solve the telomere shortening problem. And again, it's not just life, it's also health. It's going to affect both our health and our lifespan. Lengthening telomeres will make us all look, feel, and behave like we're 25 again.
Yeah, I love it. Your work is targeting the root cause of aging.
I mentioned something just now about the how and why we age. I do speak at medical conferences a lot, and I explain this to doctors because doctors, in order to really control aging, they need to know what aging is, why we age, how we age, in order to know how not to age. And so I have videos of me explaining all that. My education has given me the best education possible for really understanding all that stuff. And so those videos are available on my website. If people just go to my website at www.sierrasci, that's SIERRASCI.com, the first thing at the top of the page, they're going to see this button that looks like a rectangular Twilight Zone button. They click on that button, and it takes you to a list of key videos and documentaries. And that's what the title of the button is, key videos and documentaries of me talking about all this stuff. And it's all real characterized. They can click on the links in this document. It'll take them right to the videos. They can hear what aging is, because it's not simple. I mean, most people get it all wrong. Most of the time when you talk about what aging, you talk about how and why. But so this talks just about what aging is. Then there's also videos on why we age. Okay, and I think I've already partially explained the diversity. This is why we age. The diversity that gets added to our species by eliminating the longer lived. That's why we age, but I explained it in a whole better explanation lasting like an hour. Then also how we age, and I explain all that with the frontline cells and the reserve cells and things like that, and the Hayflick limit. And then I put all that together to how not to age. But there's a whole bunch of other things I talk about too, and that's how to, one really key thing I talk about is there's more quacks and charlatans in the field of anti-aging than any other field there is. There's everywhere you look, you're going to find somebody claiming to have a product that reverses aging. And I do not badmouth these companies. I don't point them out by name, but I can tell you, we test every one of them, and we haven't found any that actually work. But I tell people on some of these videos how to know if their products work or not, and what to ask these companies. Because bottom line is that they are either intentionally or unintentionally misinterpreting their own data that makes them believe, or not believe, and then they're faking it, that their product actually reverses aging when it does not. Okay, and the only product, nutraceutical, because there was also gene therapy that I had mentioned before, but the only nutraceutical that has ever been discovered that actually does induce telomerase to slow down and possibly reverse aging is this product called TeloVital. And again, I'm not a marketer, but I'm very proud of this product. I have a lot of pride in it. I'd love to see everybody taking it, because I'd love to see everybody getting more youthfulness out of their lives. And they're not going to get it from anything else. Yeah, you can take, there are some really good products like urolithin A and nicotinamide riboside. I take those all the time. Those really help with mitochondria health, but that's just energy. Okay, I want more than just better energy. I want to look, feel, and behave like I'm 25 again, and I'm not there yet. Okay, but this product will slow it down, slow the rate of me getting away from 25, and future generations are going to actually get me there. Okay, and get us all there, and that's what I want. But yeah, so go to my website, watch those videos. I think everybody would be very educated, eye openers on the truth, because I don't talk about any theories. I talk about the facts. Okay, I don't need theories to explain why we age and how we age. It's inevitable. They're inevitable. There's no way we're not going to age unless we do it ourselves, and that's what I'm doing.
Mm.
But yeah, so go to these things. But I also want to provide my email address, because even though I spend a lot of time working in the lab, I love taking breaks, sitting down at my desk, reading emails and answering questions. I enjoy that immensely. So people are welcome to send me emails if they got any questions at all about anything with aging. And my email address is B as in boy, Andrews, with an S at the end, so like Julie Andrews, B Andrews at Sierra Sci, that's SIERRASCI.com. That's like the Sierra Mountains, which is right in front of me here, followed by SCI, short for sciences.com. And just contact me, whether, and plus, as I mentioned, I'm National Inventor of the Year in my cancer research. I've developed drugs for multiple sclerosis. I know a lot about immunology. Uh, uh, all kinds of diseases. People are welcome to contact me and ask me just about anything. And if I don't know the answer, I will tell them. I'm not gonna provide anything that's misleading. And I don't charge a penny for this. This is all free. So.
Mhm. Yeah, and you've been called the father of telomere biology. So I think if to ask anybody, you're the guy for.
Yeah, I haven't heard that before, but my first thought is like I have colleagues that might get upset with hearing that because there's people that I consider like Dr. Calvin Harley, who unfortunately passed away, but he's the guy who first enlightened me. But Michael West, Dr. Michael West, I mean, I consider Calvin and Michael West to be the fathers of telomere biology. I feel like I'm still working for them, trying to complete their goals and stuff like that. It's just that through my education, I've created all the skills such as mathematical modeling and statistical theories and construct validity. I've developed the skills to be able to make these things happen. And that's why I've been so successful at creating all these other biotech breakthroughs. And so, but I don't want to say I'm the guy that came up with this idea. I mean, the second I heard Dr. Calvin Harley talk on telomeres, I was right there at the bottom of the podium wanting to work with him. And that's what he did. He gave me, and Mike West was the founder of that company, Geron Corporation. So I went to work with them and got all the work done that they needed and made things happen. Yeah, but I'm obsessed with this. I'm not in it for the money. I just want to see the world be happier and healthier. So
I can tell. It's great. I love the passion. Everything will be linked in the description. I'm going to ask you two very quick closing questions.
before you do,
Mhm.
Touchstone's website, I'm not trying to market, but their website also talks a lot about me. I'm just impressed with how much they've explained about me and my background. People want to know more about me, but their website is, and they also talk about, they show the data that we have on TeleVital, showing that it induces telomeres. Their website is www.thegoodinside.com. I love that website. But now, what are your questions? Sorry.
No, that's fine. The first one is, what is your number one health tip? So whether that is mindset, diet and nutrition, physical, emotional, spiritual, the one piece of advice that you would like everyone to know.
Well, the one piece of advice is do a lot of things. But if I had to pick the number one most, I think it's proper exercise. Okay. Now, people often think I don't know a thing about proper exercise because I'm an ultra marathon runner. I run all the time. There's lots of data from studies that I think are totally fraudulent, saying that there's such a thing as too much exercise. I run every single day, but I've done my own studies on exercise. I've taken blood from runners before, during, and after races and analyzed them in terms of inflammatory markers, electrolytes, things like that. My belief is that consistent exercise is important. I think it's important to run every day. If it's not running, kayak, bicycle, swim, all these endurance exercise, I think it's important to do it every single day. I haven't missed a day of running in over 5 years right now. And I believe that trains your body to recognize the stress on your body as not some virus attacking you or something like that. And so you don't build an immune response, which is actually the cause of inflammation. So when you exercise every day and you keep it fun, okay, that's really important. Because if you're the type of person that like runs every 2 weeks and runs a marathon, you'll do well, but you're going to cross that finish line on your hands and knees throwing up, and you're going to be stiff as a board for 2 weeks from inflammation, because that's what inflammation is immune cells migrating to your joints to fight whatever is there causing the stress. And you get so many immune cells that you can't bend your joints anymore. Your joints are so stuffed with immune cells. That won't happen if you are consistent with your exercise and keep it fun. And like when I speak at endurance conferences, you're a runner, I'll say, don't run circles around tracks. That's too boring. It's too hard to keep. Find a way to make it fun. Go find trails to run. And if you see a coyote, go follow that coyote. Don't stay on the trail. Get some adventure in. I mean, I always say I suffer from a disorder called can't turn around disorder. Because when I get out on the trail, I say, I'm going to go out and run for 2 miles. I can't turn around. I get so obsessed with what's around the next turn, what's over the next hill, especially when I'm running on a trail I've never run on before, or even off trail. And the adventure is just something that keeps me going. That's how I do it. So like I said, I haven't missed a day of running. I run 2 miles minimum a day, but I keep it fun. And my inflammatory markers never go up. I compete in ultra marathons, 100-mile races and longer. I'd mentioned before that I used to hold the world speed record, I think during the call before, the world speed record for barefoot water skiing. But I also used to hold the world record for the most 100-mile races run in 1 year by a person. And so I never, ever, I would run these 100-mile races wishing they would never end. I was having such a great time, and I would never be sore or anything afterwards. And I would, oftentimes after running a 100-mile race, I could go out and run a 50-mile race the next day. Okay, and that's because of my attitude towards it, keeping it fun. And I also say, if it quits being fun for one reason or another, quit. Save it for another day, because you'll eventually get to a point where it's never a problem. And so these 100-mile races, I would always be finishing thinking, I had the greatest time of my life, and I kind of wish it had never ended. So that's, I think, the most important thing is consistent and fun exercise. Okay, that's probably the number one most important thing. And when I run, I always carry a digital recorder with me, okay, which is like my thoughts, because I have the greatest thoughts, inventions, ideas, and everything while I'm running, and I can never remember what they are when I get done. There's something about running, when keeping it fun and having nature and enjoying things, where your mind just explodes with ideas. And so I carry these things just because I record the ideas. And I'm literally, when I get done, I'll have 100 different messages to myself. And I'm just blown away with how great these things are. And I could never remember them by the time when I got done with my run. But it's like, there's so much to say about getting out in nature, being in exercise and having fun, etc. But yeah, that's the number one. But I don't want to say that everything else is a long away number two. I mean, there's a lot other things that are important too, but that's number one.
Mhm. My final question for you will be a more personal one. So you get to choose a number 1 through 100, and that will correlate to the question.
Okay, I'll say 100.
100. I don't think anyone's ever chosen 100. If you could sum up your life philosophy in one sentence, what would it be?
Fun
Fun.
in one sentence. Okay, so
Mhm.
not just one word. It's like, I don't know what that was. Well, that was I just got a text. Sorry about the noise. I would say like, living's the greatest thing that ever happened to us. I think I said that before, and we should cherish it. We shouldn't be thinking that we should, expect to get old and die. We should, I love living, and I think that I hate the fact that living becomes any less lovable for any of us because of this dumb thing called aging or cancer or heart disease or anything like that. And I think that's all one sentence.
I love it. It's great. wraps it up perfectly. Thank you, Dr. Andrews. I love your work. It's fascinating, incredibly interesting. I could ask you 100 more questions and still not even scrape the surface, I feel like. So thank you for your work. Thank you for your research and everything that you do for all of us for the sake of humanity and living longer. I really appreciate it. And thank you for coming on the podcast.
The best is yet to come. Thank you very much.